Hello everyone, welcome back to our channel. Already you know that what are the applications of motion in one dimension. All our speedometers, even we are doing the experiments on the rockets, how much fuel we require to go some distance and how much velocity we require to escape from the earth. Even satellites are revolving around the earth. So for each and everything measurement is required. After that we have to study on motion in a straight line. Then we should calculate the distance, velocity, acceleration with respect to time. So one of the method to analyze the things is the graphical method. Few more graphs we are going to discuss here. Our first graph in this class is we are drawing the graph between time is on x-axis, then speed is on y-axis. The question is find the ratio of distance traveled in last 2 seconds to the total distance. Total distance, it is taking how many seconds? 7 seconds. Then the speed of this one is 20 meters. So we have to find out the ratio of distance traveled in last 2 seconds. S2 by distance traveled, total 7 seconds. You know that distance generally what is the formula? Speed into time. This is the speed into time. So area under speed and time is giving the distance. But we have to find out the distance in last 2 seconds and total distance in 7 seconds. First we should concentrate. Last 2 means from D to C. Anyway, this is having which geometrical shape we are taking. This is the first part. Area of this one is, area of first part is half into base is 2 into height is 20. So this is how much? 20 meters. So S2 is 20 meters. Like that S1 we are taking part 2. So this is belongs to entire area. This graph, this is the triangle shape. So half into base into height. Here 3 seconds. So half into 3 into, this is the 20. And this is the rectangle shape. So 20 into 5 minus 3, 2. And this is already you know that this is the 20 meters. So 20 by total this is the 30. 30 plus 40 plus this one is the 20. So after simplification 30 plus 40 plus 20. This is the answer. Total ratio of the distance last 2 seconds by 7 seconds is 20 by 90. Our answer is 2.9. So when you know the speed and time graph, we can calculate the distance. In this given graph, the given data is distance we are taking on x-axis, acceleration is on y-axis. That too, this is the uniform motion, distance and displacement both are same. From this graph, how to give the relation between acceleration and distance? Here acceleration is directly proportional to displacement because it is a straight line passing through the origin. So we can get one constant A equals to kx. What is the question? From this graph we have to draw the velocity versus displacement graph. And the given hint is initial velocity equals to 0. For this, first we should find out what is the relation between velocity and displacement. Then we should make one more graph. We know that acceleration is rate of change of velocity. Here we are multiplying and dividing with ds by ds. Then A equals to, I am writing dv by ds and ds by dt. But rate of change of displacement is the velocity. So instead of second term we should write it velocity. We do the cross multiplication. V dv equals to A ds. Then instead of both the sides we are taking the integration. This formula is v square by 2. And here instead of A we are taking ks into ds. Anyway, k is the constant, v square by 2, k into, this is the s square by 2. So when we are taking both the sides root, we are getting that relation is v is directly proportional to s. Here also A is directly proportional to S means it is a straight line. After simplification we are getting the velocity is directly proportional to displacement means our answer is, it is also straight line passing through the origin because initial velocity equals to 0. So in this we know the acceleration displacement graph. From this we have drawn the velocity and displacement graph. Then come to this problem. Here what they have given, the graph is, time is on x-axis, then velocity is on y-axis. But the question is the displacement and distance travelled by the body in 6 seconds. Distance, total path length, even it is above the t term, t-axis and below that negative positive, the total path length covered by the body is called the distance. First we should concentrate on how to find out the distance. See, area of this is the rectangle, area of this part is base into height, 2 into 4, 8. And this is 4 minus 2, 2 into, and here also we should consider this is the 2. 2 into 2, 4. And third part area is 2 into 2, 4. So total path length covered by the body is how much? Here distance equals to 8 plus 4, 12 plus 4, 16 meters. But when we can go through the displacement, you know that displacement is the vector quantity. It has both magnitude and direction. Above the t-axis, this is a positive 8 meters. Then it is negative minus 4. Then plus 4. After simplification, our answer is 8 meters. 8 meters. So in this case, distance is greater than displacement. In generally also, distance is always greater than or equals to displacement. In straight line motion and uniform motion, both are same. Here in this given graph, distance is on x-axis in meters and the acceleration is on y-axis. And clearly they have mentioned initial velocity equals to 0. The question is velocity at s equals to 10 meters. Velocity at s equals to 10 meters. You know that area belongs to product of these two parameters. From this graph, this is the acceleration versus distance or displacement formula. So area of this graph is, here area is giving the acceleration into displacement. First we should concentrate on how to find out the area. There are different geometrical shapes are there. Here we should consider this is the first part and this is the second part. Then from here to here, this is the third part and this is the fourth part and this is the fifth part. So we should consider as in different parts, then easily we can calculate the area of this one. So first part area is, anyway it is triangle, half into base is the 2 and height is the 2, you are getting this is the 2. Then second part area is 8 minus 2, 6. 6 into 2. This is the 12. Then third part area is once again triangle, half into base is 2 and height is 4 minus 2, 2. Then this is also 2. Then fourth part length into breadth, 2 into 2, 4. And fifth part half into base is 12 minus 10, 2. Then height is 4. This is the 4. So total area belongs to A into S. So this is 14 plus 2, 16 plus 4, 20. This is the 20. So from this graph we should calculate A into S, and clearly they have mentioned initial velocity equals to 0. We can go through the v square minus 0 square equals to 2as formula. 2as formula. From this already you know that as equals to how much? 20 meters. So v square equals to 2 into 20, 40 meters. So velocity at s equals to 10 meters is v equals to under root 40. It should be right 2 root to 10 meters. So the given graph is acceleration and displacement. From this we can find out the velocity at s equals to 10 meters. Then our next graph is find the displacement in 5 seconds. Here total time is in 5 seconds only, and we are taking time is on x-axis. Then velocity is on y-axis. So the given data, from the given data we have to calculate that displacement in 5 seconds. This is the 2 and this is the 1 meter per second. See, displacement, you know that it is the vector quantity. We should divide, this is the first part, this is the second part, and this is the third part. So area under velocity time gives the displacement. It gives the displacement. So S equals to area of first part plus area of minus we are taking for second part. This is the displacement. Then area of third part. So area of first part, this is the triangle, half into base is the 3 and height is the 2. Plus minus, this is also triangle. This is also triangle. Here the reading is 2 meters per second. So half into 1 into 2 plus this is 5 minus 4 is the 1. 1 into 1, 1. After simplification, 3 minus 1 plus 1. So displacement covered by the body is 3 meters. So distance is the total path length. We should add all the geometrical shapes and area of that one. When we can go through the displacement, we should focus on which is positive and which is the negative. Above the time axis, this is positive. Below the time axis, we should take as a negative. Then come to this one. Here, find the distance. This is the total distance in 5 seconds. Anyway, the total time is the 5 seconds. Here also we should add the all areas. First part area. See, this is the first part. This is the second part, third part, fourth part, and fifth part. So area of first part equals to how much? Half into base is the 2 and height is the 40 minus 20, 20. This is the 20. Then second part is 2 into 20. Direct I am writing 40. Then third part is 3 minus 2, 1. 1 into 20, 20. Then fourth part is half into base is the 1 and height is the 20. You are getting 10. Then fifth part is half into base is 1, then height is 20. This is also 10. So when we are adding all these areas, we are getting the distance. So distance equals to 20 plus 40, 60, 80, 90 plus 10. The distance covered by the body in this case is how much? This is the 100 meters. This is the 100 meters.